this isn't what I was looking for, but I'll find it during our break. Okay, but these are different matrices here. So up here they're saying this is 256 by 256, 128 by 128. And then a 64 by 64 matrix down here. So in other words, you can see that it starts getting blurrier because the pixels are larger. So this is what we're trying to show you, is that the images become more pixelated, as we were showing you on the when we did that thing with the Microsoft Paint program. Remember that? Same type of a thing. The smaller the matrix, the larger the pixels look, and so you get problems with it. Okay. So in order to overcome that problem, how do you think we could overcome that problem of pixels that are too big?
The high pass.
Huh?
The high pass filter.
Okay, remember the high pass filter is going to actually make the picture worse. It's going to make it look more grainy. Okay, well let's assume that this is a 4 by 4 matrix. You can also say that that's a 64 by 64 matrix if you want to do that. Okay. What we've learned with computers is a thing called interpolation. Has anyone ever used interpolation in math before? Okay, well basically it's a process. We use it when we do plasma studies. Okay, but basically what we do is we artificially take our 2 by 2 matrix up here, and we're going to artificially expand it. Okay, so I take the numbers that I had up here. So I had, here's 10, 30, 50, and 60. Okay, and okay, so this is my original data here, and what I basically do is I add these two numbers together. So 10 plus 30 is 40, 40 divided by 2 is 20. Okay, 10 plus 50 is 60, 60 divided by 2 is 30. So all these numbers that I'm circling here are numbers that don't really exist, they're interpolated. Okay, 60, 30, 90, so that one's going to be 45. So I'm artificially creating data in here that doesn't exist to sort of fill in the gaps. Okay, this one here you can add all these together and divide it by 4. Okay, or you can add these two together. You know, basically you've got 75 and 75, isn't it? So roughly 32. Okay. At interpolation, we do this with CT scans a lot because if I'm doing a CT scan on a patient, if I scan every centimeter, the patient gets a really high radiation dose. But if I scan every other centimeter, okay, it creates gaps of information here that I use the computer to interpolate and fill it in. Okay, so when we do helical scanning with CT, and then another application of this interpolation is something that we'll learn later when we do plasma volume calculations. normally you're going to inject I-125, RISA, or radioiodinated serum albumin, and you collect a sample at 5 minutes, or actually 1 minute, 2 minutes, 3 minutes, and so you get data at 1, 2, and 3 minutes. But in order to calculate plasma volume, we need to know what the time or what the amount of counts were at time 0. So let's say here there's 5,000 counts here. Let's say that there's 2,000 counts here and there's 1,000 counts here. So you plot this data, and I would then ask you, okay, how would you know how many counts you have over here at time 0? This is the number of counts up here. So here's 8,000, 7,000, 6.
That a syringe before injecting it?
No.
Just plot it and do it.
Well, see, I don't know what this is what I need to calculate over here, don't I? So, and I've got 3 data points over here. Now, the bad thing about plasma is that it doesn't stay in the blood vessel. It kind of starts leaking into the tissues and stuff. But, so I need to find out what's going on in here. Basically, all we do is we just create a straight line through the data points, and that'll tell me what my counts were at the beginning. So if I just connected the dots on those, draw a straight line, and then continue it to the abscissa, then I know what the counts were at time 0. So those are 3 applications of interpolation. We use it for calculating time 0 for our plasma volume studies. We use it to artificially create data between slices and scans. And we also use it to make our image. You know, remember, you acquired this stuff at 64 by 64, and it's going to look like garbage. So we interpolate it to 128 by 128 simply by artificially expanding the matrix and calculating the average in between the pixels. Okay. Let's see what else we can find about SPECT imaging, because let's take a look at, let's go back to my original handout here. Okay, we'll take a look at this one here for a minute. Actually, why don't we take about a 5-minute break? Want to take a break?
Yeah.
Want to take a 6-month vacation?